So I didn't hear anything specific, so I don't know exactly what we should look at.
How about we look at the Earth's on the homework assignment?
Well, I don't know which one's the worst. It's up to you. You know, everything's easy for me while I'm kidding. It's just you have to look and see. I don't see anything difficult overall in the homework assignment. There will be a couple problems still related to 3.2 with the new section 3.3. Okay, so is anything specific? Again, I don't know. I'm just scrolling here through the problems, but there's nothing complicated really that I see that you should stop. Let's take a look at number 13, okay, just quickly. So I'm just going to bring this one up. So here's number 13. There are a couple different things here. And I would like to focus more on the quotient rule at this moment than the product rule. So it's either B or C. So we have values here. And what we have, I'm just going to write it down, okay? So I'm copying, but it's f of 5 equals 1. You have different values, but that's not a big deal here. So what I'm doing right now, I'm just copying those values on the paper. All right, so I don't know, we can pick B or C, it doesn't make any difference. So the question here to find, let's go with B. All right, so let me show you what I have. So this is what we're looking for. So before, we have to do with derivative at 5. First, we need to find derivative with x. It's kind of general, okay, idea. So we have f over g and prime of x. Let's put it this way. And we have to take the derivative. So now we don't have any specific function. That's okay, because at least we have the ratio. That's what we have. And we can just go with the formula, nothing else. So the formula, if you remember, says we take the bottom one square, right? And you have to memorize the formula. You don't want to miss any problems on the next exam just because you don't know the formula. So we have here g, and I can put of x. Let's just put x here. So we get g of x times by f prime of x minus, and what do we have here? What do you remember?
E prime of x.
Okay, I'm just going to put f of x times by g prime of x. So as you see, there's nothing specific here, but remember, this is just setup. But our goal is, again, to go to this. But please don't start working with 5 right away. Just first get with x and then go to 5. So now what do I have? I have g of 5, f prime of 5, minus f of 5, g prime of 5, over g squared of 5. And then we look at this expression and just pick the values, plug them in. So what is g of 5? It's negative 9, right? So we get negative 9, and then f prime of 5, we have 7 minus f of 5 is 1. G prime of 5 is 3 over, and then we have g of 5, but we have to square that piece. So g of 5 is negative 9, and we have to square it down. So very simple setup, as long as you take the derivative right. Okay? Nothing specific, speaking about what functions we have, but just what we have is just enough. So, negative 9 times 7, what's that?
Negative 63.
Minus 3 and over 81. So we have negative 60
6. And negative 66 over 81.
over 81. If we can reduce something, we should, right? Do we have anything to reduce here?
Yeah, you get negative 20 over 27.
So negative 20. So you're dividing by what?
I don't know, it's plugged into my calculator.
You just plug it into your calculator. Okay.
Wait, no, wait, wrong button. Okay, 22 over 27.
Okay, so I know you were wrong. Okay, so negative what? 22. That means we divide by 3, right? Over 27. Well, and this will be the final answer. So that's the idea, okay? And many similar problems you will see when we have the values, no specific functions, and you just have to use the rule and then substitute. So that's what we have for this one. Okay? All right. So, I mean, like I said, there's not that many problems that I have to show you because we're just taking the derivatives. And again, the problem can be find the equation of a tangent line. So we know we have to take the derivative, substitute x, get the slope, and write equation of the line. Or speaking about normal line again, you know, the normal line is the line that is perpendicular to the tangent line to the point of tangency, right? So we'll get the slope of a tangent line, then do negative reciprocal, and that's the slope of a normal line. And write equation of a line. So let's keep going, and let's just get to section 3.3, and that's where you're going to show me all your skills in trigonometry. So section 3.3, we're talking about derivatives of trig functions. So derivatives of trig functions. Now, I'm going to give you formulas, or rules, let's say, and you have to memorize those. They're easy right now at this moment. When we get to the derivatives of inverse trig functions, they will be more complicated, so you have to be very careful with the signs and square roots and other things. But right now, they're very simple. Now, you should know those, okay, from the vocab. Okay, but let's just write them again. So, for example, if I have derivative of sine of x, what did you learn? What do you remember?
Cosine x.
Good. So that will be cosine of x. And again, we're just using this as a fact. And as I told you, I think, if you would go to the book and see how they got this, there's like 2 pages of work to get this little fact. The derivative of sine of x is the cosine of x, okay? But it's a lot of work goes into this to prove. But we're going to use it, and that's it. So then we have derivative of cosine of x, and that will be, what do you remember? So this will be negative
Just negative sine of x, right? Yeah.
sine of x. So these two are basic. Okay, these two are basic. Everything else we can prove or find using these two. And I'll show you the problem where it says to prove the derivative of this function is this. So these ones we're using to prove everything else. We don't have to prove these. But for example, if somebody says, okay, let's just find derivative or prove derivative of tangent of x, I can use these to prove. Why? Because what is tangent by definition?
Cosine over sine?
Sine over cosine, right? So we'll get to that, but basically then you can use quotient rule and prove. Okay? But we're never proving the first two. Okay? These are facts. The rest we prove. So what do you remember about derivative of tangent? Anything?
X squared.
It will be secant squared of x. So memorize them, okay? It's fine right now, okay? This is the first time you look at it once. I understand. But overall, you need to know that. So these kind of first three, then we have, for example, cosecant of x. And the derivative is negative cosecant of x times by cotangent of x. And like I said, we can prove them. And let's say secant of x, and this will be secant of x times by tangent of x. And the last one, we have cotangent of x, and this will be negative cosecant squared of x. So for now we're going to stop here, because we'll get to the inverses later, but that's what we have. And you have to memorize. So quickly, if you kind of look carefully at all of these formulas, you should see that every function that starts with c has negative derivative. Yes, no?
Oh, yeah. Yes.
So cosine, cosecant, and cotangent, all of them are negative. So at least you will not miss the sign. And the rest you just have to memorize. So let's just take a look at the first problem. Keep these somewhere that you can just glance at them and know where we're going to put. But let's just put example number 1, and let's just put this. Let's say I'm going to put prove, and what we're going to prove, and I'm going to use d over dx, like book kind of used, but we know it's a prime, so we shouldn't have any problem to recognize this. So we're going to prove that the secant of x is secant of x times by tangent of x. And again, when we say to prove, we have to show work. It's not like what it was in the table. No, we're not talking about this. You have to show your work, how this can be done. So remember I said, we're using the first two from the list, sine and cosine, to prove the rest. So what that means, you have to change your secant to something that has sine, cosine in it. So what is secant?
1 over cosine.
So yes, it's 1 over cosine of x, and I'm just going to put like this with prime, okay? Remember we said this d over dx is kind of fine with this. Control room, can you adjust kind of the resolution a little bit, please?
Not resolution, but contrast.
Somebody's there? Well, let's keep going. Eventually we'll get it better. So, what do we do now? Do you see fraction, right?
They don't suggest.
So we'll go with the quotient rule.
Yeah.
So here we'll have cosine of x squared, and then if we go with the rule, it says the bottom one times by derivative of the top, right? And the top is 1. So what's derivative of 1?
0.
Do you need me to look at you to know that you're wrong?
No.
Okay, so derivative of 1 is what?
0.
0. Okay, so times by 0, again, according to the rule, if you look back, for example, at this formula right here, so f prime, that's the top one, minus, then what?
1 times cosine x prime.
Okay, and cosine of x prime is
Negative sine of x.
negative sine of x. Alright, so we're done with the derivative. Now we just have to simplify it. So cosine of x times 0 is 0, so we don't have to worry about this. Okay? Then we have negative, and negative gives us positive. So we have sine of x over cosine of x squared. So that's what we have. Well, obvious, if you look, this is what I have, right, as the end result. This one doesn't look like this one. But can you modify this one to achieve this? Get this one.
Yeah. Sine x, cosine x.
Can you?
Yes.
Probably. Well, yeah, that's a good guess because we're doing everything right? So what do we do?
So you can take out a sine x and a cosine of x to get out a tangent, and then.
Good. So, absolutely right. But I'll kind of follow this setup, so I'll put 1 over cosine of x times by what?
Sine of cosine.
Sine of x over
1.
Cosine of x.
cosine of x. Can you see that? Yes, cosine. I split it cosine. So now we know that this one is secant, and sine over cosine is tangent. And we're done. Okay, it's a very simple problem. Similar problem, I can tell you in the future, similar, you have on your final exam where you have to prove one of these. Should be very easy. And then we're just going to go and start working with just the derivatives, okay? So, any questions about number 1? Yes, no?
No. No, I think
Alright,
we're
so
good.
let's go. You have a question? Sorry, I kind of missed that.
No, we're good.
Okay, so with number 2, so let's just get this function. So I have g of theta, and we have e to theta times by tangent of theta minus theta. So since we have trig, you're going to see all those Greek letters, okay? Thetas, alphas, betas, and all that stuff. So keep in mind that you can have those. It's very important to know if they are the variables or maybe constants. And it's easy to see from the name g of theta, right? That theta is the variable, like x. But pay attention because sometimes we have some formulas, let's say from physics, specifically like something comes from optics, okay, or maybe engineering, where we have big formulas and they have lots of different letters. A, B, C, and all that. So you have to be careful to know which one is the variable. Okay, so keep that in mind. Well, definitely we see the product rule here, right? Can you see the product rule?
Yeah.
And we can take the derivative. Now, if some of you, for example, like to open parentheses, let's say you want to distribute e to theta, you can do that, but that doesn't make it easier because you still have the product rule. So let's just keep it like it is. So if you go to g prime of theta, I'll do this step by step, putting primes, and then quickly we'll take the derivative. So we have e to theta times by derivative of tangent theta minus theta prime. Like I said, just going to put primes first time right here. Plus, then we have tangent of theta minus theta times by e to theta. And that will be prime, as I said. So, e to theta, and then we have to take a derivative. So we have a difference here. So we take a derivative of each term. So what's the derivative of tangent theta? You can look.
It would be secant squared theta.
So secant square of theta, good. It's very important to pay attention to the parentheses. You will see the nightmare if you miss out on the next exam. It's very difficult to find what went wrong, or just basically you get the wrong answer overall. So minus, what's the root of theta?
0. What would it be?
It's just
1?
It should just be 1, right?
Okay, so now you're confused, but remember theta is like x. So if I will ask you what's the root of x, what do you say?
It's 1. It's 1.
It's 1, right? So theta acts the same way, so don't get confused, it's just 1. And then we have tangent of theta minus theta, nothing happening to this. And then derivative of e to theta. Remember, well, the only function that doesn't change the look, if you take a derivative or some other things we're going to do later, will be the same. So that's your derivative. But we can do more, we can simplify. So let's see, can you see anything?
You can take out the e to the theta's power.
We can do that, okay, so that's a good step, yes. So we can pull this outside. What's left? Secant square of theta minus 1 plus tangent theta minus theta. Good. Can you see any of the identities? Remember, we're talking about trig. They will come in.
Secant squared minus 1 is squared?
So, anything? So something familiar, right? Secant square of theta minus 1. Okay, good. So what's that? So it's the tangent, that's right, tangent squared. But it's not exactly like the identity. This is modified kind of, because if you, for example, look at your list of identities, maybe you have one pre-calculus. Hopefully you kept those because you have to refresh the unit circle and all the other things. So if you remember or look at the paper, it's written like this. I'll put data here. So this is how identity looks like.
Right.
Okay? But you can see if you do secant squared minus 1, what do you get? Tangent squared. Okay, so not everything will be so clear and visible right away, but you have to get that feeling because I hope you had enough of those identities that you will kind of feel like it's right here. So, what do we have here to finish? E to theta. This turns into tangent squared of theta plus tangent of theta minus theta. Now you can ask more questions like, can we still do something here? Well, the answer is no. There's nothing else you can do here. This is the end because there's no like terms to combine. There's nothing you can still pull out. Remember, you cannot pull out theta. Okay, it's I would call it argument. Okay, you cannot do it. You cannot pull it. So that's the answer. Do you have any questions? Okay, so then maybe you say like, we have lots of identities. Yes, you have those, and quite a few. But in Calc 1, we're not using a lot of them overall. And basically basic ones, like sine squared of x plus cosine squared of x equals to what? 1, right? Okay. The other thing is, for example, can you tell me what is sine of 2x?
It is.
Anybody? Sine of 2x.
Oh, it's just it's just 2 sine x, right?
Yeah, 2 times the sine of x.
Oh, that's too easy.
Right?
Yeah, that's too easy. And this is not the right answer. Something's missing.
You have to square it again, right?
Nope.
True.
All right. Well, I'm not gonna wait. Okay. You can check. This is not the exam. Okay. But at least you'll have kind of good or bad feeling, like forgot. Okay. Well, this will be times by cosine of x. So we might have to go back and forth, you know, from sine of 2x to 2 sine cosine, or from 2 sine cosine to sine of 2x. Okay. Either way, you have to remember this. Okay. Let me see. Okay. You kind of forgot the easiest one. Let's see if you remember this one. All right. So yes, no.
Vaguely.
All right. So, well, I'm going to write it. So this one is cosine
of x plus x.
squared of x minus sine squared of x.
Yeah.
So find your papers. I hope you still have them, or just go online and get them. Okay, keep them in front of you. But what I'm saying to you there's some basic identities that you need to know. I'm not talking about some crazy one that's like half angles or some other things, okay? Mainly we deal with double angles. What the one that we have, I just mentioned to you, sine squared of x plus cosine squared of x, that one, okay? We're talking about this one, the unit circle identity, all this. But not something too big, so basic, and the main thing is the unit circle, so please remember this. So, as I said, with the example, there's nothing else we can do with that. Okay, we use the tiny little identity, and that's all we have. So let's take a look at one more. So let's say I have y equals t sine of t over 1 plus t. So we're going to take the derivative of this function, and if you look carefully, you should see that we're going to use two rules. We're going to use product rule and, can you see product? And
Yeah.
quotient rule, right? So we have product and quotient in one problem. This is just the beginning. Because later on we'll go to section 3.4, we call it chain rule, and then you'll get problems where the product, quotient, chain, and everything together. So that's where you have to be very careful, putting everything on the paper to make sure if you make a mistake, you can go back and find it. Because you really have to practice for finding those mistakes if you make one, let's say. So let's go to this, and I will write this again with step-by-step process. So we have this on squared. Then we have 1 plus t, and here we have t sine of t with the prime, because we're looking for the derivative of that one, minus t sine of t, and times by derivative of 1 plus t. So this is the setup that we have to use. So, 1 plus t squared. Don't rush to open parentheses because you think you know or you can to open them. Wait. Sometimes we have to open parentheses, sometimes we do not have to. So please just wait for this one. Don't rush. And here we have 1 plus t. And now we have to take the root of this one, t times sine of t. And this is just the product rule. So we have 1 times the root of sine of t is what?
It would
Cosine
be
T.
yeah, cosine t.
Plus, and then we have sine of t and times by derivative of t, which is
1.
1. So times by 1. So that's this piece, okay, derivative of this one right here. See, it's getting large now. And minus t sine of t, and what's the root of 1 plus t? It's 1. Okay, we took the derivative. We cannot stop because at least there one thing can be simplified here. And if you look carefully, if you open parentheses, you're going to have t sine of t and minus t sine of t. So you can cancel that piece. So we have to open parentheses. I know it looks large and big, but this is the binomial 1 plus t, and also this one the binomial. So basically you have to use FOIL to open parentheses. Okay, it looks big, large maybe, but it's just FOIL. So what do we have? We have t cosine of t plus sine of t plus t squared cosine of t plus t sine of t, and minus, now going to this one, t sine of t over 1 plus t quantity squared. So if you look, these two can be canceled. And now we have this piece, and you can leave it in this way because there's nothing can be done. You cannot make it smaller. This can be the answer, okay? You can just leave it like this, like I said. But also, you can make a tiny bit look better. But it's not really simplifying, okay? Because if you look careful, let me kind of regroup them, okay? So for example, t cosine of t plus t squared cosine of t plus sine of t over 1 plus t quantity squared. Like I said, these two are perfectly fine to be the answers. But, like I said, this is just for the look, nothing else. If you look at the first two, just the first two right here on the top, you can factor out t cosine of t. Can you see that? Only from the first two. Again, I'll repeat, this will not simplify anything. It will make it look better, nothing else. So if I pull out t cosine of t, so what's left over here? Will be 1, good. What's left here? Just t plus sine of t and over 1 plus t quantity squared. And that's it. It just has a different look. Now, if some of you have this kind of great idea, let's start canceling something here, the answer is no. You cannot cancel. You can only cancel if they are factors. They are not factors. It doesn't work that way. And this is the final answer, and we're done. Do you have any questions?
How
Not all, but some. And like I said, when we get to more rules and properties, they can be put into one problem. So they're a long process to go through the process. Also keep in mind, if your function, let's say from the beginning, kind of looks big, like has a complex fraction, fraction and fraction, then you probably should reduce them first before you get into big process of finding derivatives. Okay, so that's that one. All right, so let's just do, well, you will have problems to find equation of a tangent line, okay? You know what to do with this. You know that you have to take derivative, you know that you have to take x value, substitute, right? Get the slope of the right equation of the line. The same thing with the normal line. But please, one thing that you have to remember. If we talk about trig, we're putting exact values. We're not trying to convert decimal, your answers into decimals, you understand that? So that's why I said unit circle. We're not trying to get square root of 3 and then put it as a decimal, and nobody's saying to what round, and then you taking this into your own hands and saying, I like to round this to only 2 decimal places. There's nothing will be saying, you will not see anything saying round, unless, let's say, specifically says to round. So keep in mind, if we talk about trig, we're using exact values. So refresh the unit circle. So, just kind of to get to the end. You're also going to have a couple of problems with the limits with trig functions. But those problems are based on the certain concepts, okay? They're not just random problems with trig. They base on a certain concept, and actually I have 2 of those. The first one is this. Limit of sine of x over x when x is approaching to 0 is 1. And this limit was basically developed, or they proved this limit when they were looking for the derivative of sine of x. Remember I said 2 pages, right? Just to get this simple concept. Along the way, when they were doing this came in and they had to find what that is. They did it. Okay, that's this one. And then another one that they have is this one. So these two